Greetings everyone and welcome back to my channel. This is July the IT guy and I'm back here with another Cisco Packet Tracer Lab. Today's lab is Tracer Lab 3.5.5 Configure DTP or Dynamic Trunking Protocol. So please make sure to like and subscribe for future videos. So let's get started. What is DTP? According to the CCNA curriculum, Dynamic Trunking Protocol or DTP is a Cisco proprietary layer 2 protocol used to negotiate a trunk link between two switches. It manages the state of the trunk by automating the process of choosing between access, a single VLAN, or trunk, multiple VLANs mode. So in the context of the CCNA exam, you should focus on these specific operational characteristics. The 4 DTP switch port modes, which are access, trunk, dynamic auto, further broke down into trunk or desirable, and dynamic desirable, which also have trunk, desirable, or auto. Alright, so let's take a look. We are given an addressing table. We have 1, 2, 3, 4, 5, 6 PCs or end devices, and we have 3 switches, naming conventions S1, S2, S3 on VLANs, VLAN 99. And we are given an IPv4 address with subnet mask of /24. Alright, so what are the objectives here? So let's see: configure static trunking and configure and verify DTP. A little bit of the background scenario. As the number of switches in the network increases, the administration necessary to manage the VLANs and trunks can be challenging. To ease some of the VLANs and trunking configurations, trunk negotiation between network devices is managed by the Dynamic Trunking Protocol or DTP and is automatically enabled on the Catalyst 2960 and Catalyst 3650 switches. In this activity, you will configure trunk links between the switches. You will assign ports to VLANs and verified end-to-end connectivity between hosts in the same VLAN. You will configure trunk links between the switches, and you will configure VLAN 999 and the native VLAN. Alright, so let's take a look. What are the instructions on part 1? Verified VLAN configuration. So verified the configure VLANs on the switches. Alright, so on switch 1, let's go to privilege exec mode and enter the show VLAN brief command to verify the VLANs that are present. Alright, so let's go over to our lab here, go over to switch 1. We are on the command line interface. Let's enter. And let's go to privilege exec mode by entering the enable command. Now let's do the show VLAN brief command. And there we have it. So we see that we have the default configuration. Well, actually, we see that besides the default, which is VLAN 1, we also have 2 extra VLANs. VLAN 99 for management and VLAN 999 for native. Alright, so let's continue. So repeat steps 1A on switch 2 and switch 3. Alright, so let's go over to our switch 2 and let's escalate to privilege exec mode and enter the show VLAN brief command. Alright, so we see that we have the native VLAN 1 and also VLAN 99 and VLAN 999 on switch 2. Let's go over to switch 3 and again enter enable and the show VLAN brief command. Okay, so we see that we also have the same configurations of VLANs, VLAN 1, the default, VLAN 99, and VLAN 99. Alright, so let's continue on part 2. Oh, okay, there's a question. What VLANs are configured on the switches? So as mentioned earlier, we saw that there's VLAN 1, which is the default VLAN, VLAN 99. Let's just open the command CLI, and VLAN 99 for management, 999 for native, and then the reserve VLANs, which are 1002 to 1005. Alright, so part 2, create additional VLANs on switch 2 and switch 3. So on switch 2, create VLAN 10 and name it red. So let's go over to our switch 2 here and let's enter global configuration mode. And let's start creating those VLANs by simply inputting the VLAN command and then giving it the corresponding ID, VLAN 10, and the name is red. Let's go ahead and do that. So, and then part B, create VLANs 20 and 30 according to the table below. Alright, so we have 2 extra VLANs, VLAN 20, again, VLAN command, VLAN 20, and the name is blue. and then VLAN 30, and the name is yellow. So this one's switch 2. Let's go over to our switch 3 and configure with the same VLANs. So let's go over to global configuration mode, and let's start with VLAN 10. Name is red. VLAN 20. Name is blue. And VLAN 30. Name is yellow. Alright, perfect. Oh, and also let's configure those VLANs on switch 1. Let's enter our configure terminal command. Let's input VLAN 10. Name is red. VLAN 20. Name is blue. And VLAN 30. Name is yellow. Alright, there we have it. So it's completed. Alright, so let's go on and see. Verify the addition of the VLANs of the new VLANs. Enter the show VLAN brief at the privilege exec mode. In addition to the default VLANs, which VLANs are configured on switch 2? Alright, so let's go over to our switch 2. And let's exit this interface. And let's input, we need to exit the global configuration mode and go to user privilege exec mode. So now enter the show VLAN brief. Alright, so in addition to the default VLANs, which VLANs are configured, and we can see here that we have now the VLANs we just created, which are VLANs 10, 20, 30, and then 99 and 999. Alright, so part 3, assign VLANs to ports. Use the switch port mode access command to set access mode for the access links. Use the switch port access VLAN ID command to assign a VLAN to an access port. Alright, so in this case, part 8 is assign VLANs to ports on switch 2 using assignments from the table above. Alright, so we can see here that on switch 2, we are configuring access ports and giving it the corresponding VLAN. So let's go over to our lab, switch 2. Let's enter global configuration mode by config T, and let's move this over so we can see. So now we need to input the following command, which is interface range, since we're configuring a range of ports. Fast Ethernet 0/128, and this would be access mode. So this therefore is switch port mode access. And now let's exit. Or actually, let's go back because we need to assign the VLAN 10. Alright, so let's go back to the interface range. Fast Ethernet 0/128. And let's give that switch port access VLAN 10. Now we can exit. Let's enter interface range. Fast Ethernet 0/9216. Switch port mode access, and these are on VLAN 20. All right, so switch port access VLAN 20, and let's go ahead and configure the last set of ports. In this case, it'll be interface exit from here, interface range, Fast Ethernet 0/17/224, and then switch port mode. Again, these are access ports, and switch port access through VLAN 30. Alright, so this is completed. So now part B, assign VLANs to ports on switch 3 using the assignments from the table above. Oh, okay. So in this case, we need to configure switch 3 with the same configuration. So let's go ahead and exit from this interface, and let's again enter interface range, Fast Ethernet 0/128, and these are access ports. So therefore, switch port mode is access, and it'll be assigned to VLAN 10. So switch port access VLAN 10. exit these interfaces, and let's enter the second set of range. It'll be interface range fast Ethernet 0/9216, and again this is switch port mode access, and these are assigned to VLAN 30. So switch port access through VLAN 30. Alright, perfect. So let's move on and see what's next. Now that you have the ports assigned to VLANs, try to ping from PC1 to PC6. Was the ping successful? Explain. Alright, so let's go ahead and try and see what happens. PC1, let's open the command prompt, and it's PC6. Alright, so what's the IP for PC6? We see here is 192. So let's do the ping command. 192.168.10.2, and let's run that ping and see what happens. Alright, so we're getting request timeout. I don't think it's going to work, but let's just wait and see, because we haven't yet configured the trunks on any of the switches. Okay, there we have it. So yeah, the answer is pretty much no. So although the PCs are in the correct VLANs and subnets, the links between the switches are currently access ports, or in the default dynamic auto mode, which do not carry traffic for multiple VLANs across the network. So yep, it's not going through. That's confirmed. So let's proceed to part 4, configure trunks. There you go, on switch 1, switch 2, and switch 3. So dynamic trunking protocol, DTP, manages the trunk links between Cisco switches. Currently all the switch ports are in the default trunking mode, which is dynamic auto. In this step, you will change the trunking mode to dynamic desirable for the link between switches S1 and S2. The link between switches S1 and S3 will be set to as a static trunk. Use VLAN 999 as the native VLAN in this topology. Alright, so part A is on switch 1 or S1, configure the trunk link to dynamic desirable on the gigabit Ethernet 0/interface. The configuration of switch 1 is shown below. Alright, so we see it here, so let's go over to our switch 1. And let's exit this VLAN interface, and let's enter the given interface of gigabit 0/1, and again switch port mode dynamic desirable. Alright, so there we have it. We see that the interfaces have switched to a state of up. What will be the result of trunk negotiations between switch 1 and switch 2? So let's see here. What would be the result of trunk negotiations between S1 and S2? A trunk will form, pretty much. Since S1 is set to dynamic desirable, actively asking to trunk, and S2 is dynamic auto, willing to trunk, they will negotiate a trunk link. There we go. So part B on switch 2 or switch S2, verify that the trunk has been negotiated by entering the show interfaces trunk command. Interface gigabit 0 Ethernet 0/4/1 should appear in the output. Alright, so let's go over to our switch 2 and verified. Alright, so we do see the commands already there. Let's see exit, and let's just do show interfaces. Show interfaces trunk command. Okay, so we see that it is on gigabit Ethernet 0/4/1. Mode is auto, encapsulation is 8021Q, and status is trunking on the native VLAN, which is 1. Alright, so what is the mode and the status for this port? Again, the mode we see here is auto, and the status for this port shows is trunking. Alright, so for part C, for the trunk link between S1 and S3, configure interface gigabit Ethernet 0/4/2 as a static trunk link on switch 1. In addition, disable DTP negotiation on interface gigabit 0/4/2 on switch 1. Alright, so let's go over to our switch 1. And let's exit this interface, and now we need to on gigabit Ethernet 0/2. It'll be a trunk port, therefore switch port mode in this case will be trunk and not access, so this mode is trunk, and we need to do switch port non-negotiate. Alright, so that's already configured. So as a static trunk, we see here is a non-negotiate. In addition, disable DTP non-negotiate on interface gigabit 0/2 on switch 1. Alright, so we see this trunk, static trunk, and it's on non-negotiate. Alright, so now part D, use the show DTP command to verify the status of DTP on switch 1. So let's go ahead and do that. Let's enter in. Let's do show DTP. What do we get? We see here's global DTP information, sending DTP hello packets every 30 seconds. Dynamic trunk timeout is 300 seconds. One interface is using DTP. In this case, we see that it's on interface gigabit 0/2. Alright, so part E, verified trunking is enabled on all the switches using the show interfaces trunk command. So again, let's do show interfaces trunk on switch 1. Show interfaces trunk. Now we see that we have two interfaces. So gigabit 0/1 is desirable, trunking on native VLAN 1, and gigabit Ethernet 0/2 is mode is on. It's 8021Q and is trunking also on native VLAN 1. What is the native VLAN for these trunks currently? Alright, so as stated earlier, these are trunking on VLAN, native VLAN 1. So part F, configure VLAN 999 as the native VLAN for the trunk links on switch 1. Alright, so let's do that. So let's go over to our switch 1, enter config T. Interface range, gigabit 0/122. And let's give that command of switch port trunk native VLAN 999. Alright, so what messages did you receive on switch 1? How would you correct it? Oh, I see here. So we are getting a mismatch, native VLAN mismatch discover on gigabit 0/2, and native VLAN mismatch discover on gigabit 0/1 on both switch 3 and switch 2. Okay, so in this case we need to ensure that the two other switches, in this case switch 2 and switch 3, are configured with the native VLAN 999 to match this port. So let's go ahead and move to the next part. So part G would be on switch 2 and switch 3, configure VLAN 999 as the native VLAN. That's correct. Alright, so let's go over and do that. Let's get that out the way, and let's configure switch 2. And we see we get the same corresponding messages indicating a mismatch on the native VLAN. So let's go ahead and configure and fix that. So config T. And this would be, let's see, on switch 2. So this is interface gigabit 0/1. And this will be switch port trunk. Again, native VLAN 999. Alright, so switch 2 is configured. Now let's do the configuration on switch 3. And let's exit, or let's just end this configuration, and let's enter global config again on interface. And this one, it was mismatching on, let's take a look here, switch 3 on gigabit 0/interface, and same command would be switch port trunk native VLAN 999. All right, so now part H, verify trunking is successfully configured on all the switches. You should be able to ping one switch from another switch if the topology using the IP addresses configured on the SVI. Attempt to ping from PC1 to PC6. Okay, let's do that. See if it works. So from PC1 to PC6. All right, let's wait for the results and see what happens. Okay, we see we are getting request timeout. All right, so let's see what's missing here. So we see we have 80% completion rate. So let's take a look and see what's missing. Okay, so the misconfiguration or pending configurations in switch 3. So it's fast Ethernet 0/11. Access VLAN is incorrect. Fast Ethernet interface 020. All right, so let's go ahead and do that. So in switch 3, let's exit. And let's take a look here. So switch 3. This would be a non-negotiate. So let's go ahead and enter interface. Okay, so we are seeing native VLAN mismatch discover on switch 1. So let's do this. So interface. This would be an interface gigabit 0/2. Switch port mode is trunk. Switch port would be non-negotiate, and then switch port trunk again is native VLAN 999. All right, so that's completed. Now we see we have 93% completion. So what else is missing? Let's take a look here. So these two interfaces, fast Ethernet 0/4/11 and fast Ethernet 020. Access VLAN is incorrect. So let's end. All right, so let's configure. These interfaces would be assigned to, so ports 11 and 20. Let's go ahead and input the range. So in this case, let's do the switch port interface range, fast Ethernet 0/2/16. We mentioned switch port is access, and again let's give that the correct VLAN. So this would be switch port access VLAN 20. And let's exit this interface and let's give it the last interface range. So in this case, this interface range fast Ethernet 0/17 to 24. Switch port mode again is access, and we need to assign it to VLAN 30. So switch port access VLAN 30, and I think this should complete the task. Let's go ahead and confirm. Yep, there we have it. So let's end, and now we should be able to ping to verified from PC1 as indicated earlier to PC6. Let's take a look here. Yep, it is confirmed. So it is we are getting responses. PC1 is able to reach over to PC6. So the interface goes to switch 2 gigabit 04/1 to switch 1, and then it goes out through that interface gigabit 04/2 trunking port, and then it goes over to switch 3 over to PC6. All right, so it is confirmed. Why was the ping successful? Oh, okay, why it is explained. Hint, look at the show VLAN brief output from all 3 switches. Compare the outputs from the show interfaces trunk on all switches. All right, so we can do that quickly. Let's take a look here. Bringing this back here, and let's do end show VLAN brief. This one is on switch 2. Show do. Let's actually exit here, and let's do a show VLAN brief. Same on switch 3. Show VLAN brief. And let's take a look. Part J, correct the configuration as necessary. All right, so we've done that. In part 5, reconfigure trunk on switch 3. Part A, issue the show interfaces trunk on switch 3. And let's see here. Well, it's already completed. So since we already have completion of 100%, this lab is completed. Let's check the results. And again, we've configured switch 1 ports interfaces as a dynamic mode in native VLANs. On these 2 interfaces, gigabit 04/2 dynamic mode, native VLAN non-negotiate port mode, and the corresponding VLANs 10, 20, and 30. Switch 2 ports on fast Ethernet 04/1 as an access VLAN, fast Ethernet 012. Again, access VLAN. Ports fast Ethernet 04/20, access VLAN, and gigabit Ethernet 04/1 as a native VLANs. And we have configured VLANs 10, 20, 30. And lastly, on switch 3, ports of fast Ethernet 04/11, 20 are access VLANs and access ports. And lastly, gigabit Ethernet 04/2 is a dynamic mode, has the native VLAN and is non-negotiate, and it has again the corresponding VLANs 10, 20, and 30. Thanks everyone for joining me again on another packet tracer lab here on my journey to acquiring my CCNA certification. Again, it is very important to practice on these labs to gain more experience as this simulates real-world scenarios. So please make sure to like and subscribe. I'll be bringing in more packet tracer labs in the near future, and I will see you guys on next video. Thank you. Have a great day.